Hello guys, welcome to Backbencher Studies channel. In the last video, we discussed how we can plot the root locus based on three rules and based on events conditions. We discussed three rules, and based on that will be more clear when we solve problems. So moving on to next rule, that is rule 4. We saw that in rule 2 there are branches which are going to infinite. So so any branch which is going to infinite for any curve have asymptotes. What are the angle of asymptotes that curve is having? So we have to find out the angle of asymptotes. That is what rule 4 is stating us. So the angle of asymptotes of this branches going to infinite is given by plus minus 2q plus 1 into 180 by p minus z, where p is the number of poles and z is the number of zeros. So from q equal to 0 to p minus z minus 1, we have p minus z number of asymptotic angles. Based on that asymptotic angles, we can draw asymptotes at that particular angles. So this is how we can find the asymptotic angles. And moving on to rule 5, we have the centroid. So these asymptotes which are tangential to the branches which are going to infinite at s equal to infinite, then they will be meeting at some point. What is that point is called centroid of the asymptotes. So the centroid of these asymptotes can be calculated by summation of real part of finite open loop poles minus the summation of real part of final open loop zeros. So this is how we can find out the centroid of the asymptotes. And what is breakaway point? So moving on to rule 6, we have the breakaway point, where the point at which we have multiple roots or which are equal. So that is what we call it as breakaway point. That means they are the root locus plots are in such a way that they are moving towards one each other, and they will be splitting in their directions. The point at which they split in this direction is called what is called breakaway point, or the point at which we have the multiple roots are called breakaway points. And this is break-in point, where infinitely branches which are coming and meeting at some point. That is what we call as break-in point. So we can find out the breakaway point or break-in point based on equating based on the roots of the polynomial dk by ds is equal to 0. So we have the characteristic equation as 1 plus k times g is equal to 0. If we if we move that plus 1 to this side, then we have k into g is equal to minus 1. And if we find out the value of k, then we have k is equal to minus 1 by g over here. So where g is the open loop transfer function, which is the product of the open loop poles and product of the open loop zeros. So that polynomial we have to differentiate with respect to s, and if we equate that polynomial to 0, then the roots of the this corresponding equation gives us the breakaway points of the root locus. So, and angle of departure, this is the very important rule. So if we have a pole pole zero system like this, then how they are moving, like how they are moving, that is given by this angle of departure or angle of arrival. So the angle of departure or arrival can be calculated as the corresponding angles. So this is a corresponding point, we are assuming that it will be on root locus. So we have a pole, a zero, a pole, zero, pole, zero, and zero over here. So for this point to lie on the root locus, we need to satisfy the Evans condition. That is, the angle of this point correspondingly is should be the sum should be equal to the odd multiple of 180 degrees. So we need to equate that. So the corresponding points angle from all poles, we need to take that, and we need to uh, do the summation with corresponding sign. Like if we have a zero, then we have positive positive angle, and if we have a pole, we have negative angle. That was pretty straightforward, because we have zeros on numerator and poles on denominator. So if we take the angle, we have angle summation of angles of poles of zeros minus summation of angles of poles is equal to odd multiple of 180 degrees. So by taking this condition, we can find out the angle of departure, so or angle of arrival. That if we take off this corresponding theta 2, which is the angle of departure of this point at this pole, at this or at this zero, that is theta 2, we need to take out. So we need to place theta 2 in this side, and if we move all of these other angles to the other side, then we can have the angle of departure of this corresponding zero which is present at here. So this is how we can find out the angle of departure. So that's all for today, guys. I hope you understand all the rules. In the next lecture, we will be solving the problems based on root locus. That will be more clear for you. Thank you, guys.